Hello, and thank you for joining us for this session on lightweighting. Now, demand for range has pushed lightweighting to the top of the agenda for a lot of EV manufacturers, as the engineers are balancing cost, performance, and safety concerns around vehicle structures. And with evolving searches for optimum blend, what's the impact on the manufacturing processes involved in creating those vehicle structures? And how are materials like aluminium and advanced high-strength steels, composites, impacting on production processes for body and chassis, and how are they being applied? To get a clearer picture on these developments in this area, I'm joined by three experts and materials and vehicle structure. So I'm really pleased to invite to welcome onto the screen Ignacio Martin, who's Body in White R&D Director at Gestamp. Ignacio has led the R&D at Body in White Gestamp since 2014. Playing a role in Tier 1 suppliers' body and chassis innovation. Also joining us is Professor Wolfram Volk, who's the Chair of Metal Forming and Casting at the Technical University of Munich. Wolfram has been head of the Department for Forming Technology and Casting at the Technical University since 2011, and he's also a member of the management for Fraunhofer Institute for Casting, Composites and Processing Technologies. And we're also joined by Jerome Favreau, Head of Automotive Steel Solutions at ArcelorMittal's Global R&D Department. Jerome is in charge of piloting engineering activities for automotive applications and customers, including areas such as forming techniques, sustainability, and additive manufacturing. I can personally vouch for their level of expertise on this panel. I'm delighted to have them all here. You may well have read pieces involving or around them over the last few years in AMS. But let's get the ball rolling straight away. And something that came to light a few months ago, and we covered reasonably heavily, was Volvo's decision to use a megacasting process to create part of its floor pan on its new electric vehicle platforms. It was an interesting one. I mean, we've seen this technology used or deployed in a similar way by Tesla, I think, were the ones that were the ones that were most publicized. Volvo have taken the decision to go down the route, and I understand it's not necessarily new technology, but I think maybe the application in this instance is relatively new at the moment. If I might go to Wolfram first. When we published our article on Volvo, and we spoke to the guys there about that, but actually you'd also produced or been involved in an interview where you were discussing the sort of pros and cons around this and your perspective on that. Could you just give us a bit of an insight into how you see that side of things, the megacasting, the aluminium megacasting in this instance?
Yeah. So I think it's a really interesting topic, megacasting, but it's not, from my perspective, the main reason of lightweighting. For my side, it's integration technology to reduce efforts of body in white and also reduce costs in a press shop. So I think this is a main driving topic because we are reducing the number of panels which we are using in the body in white. So we have less joining technologies, and with this integration aspect, it's let's say quite fast, and hopefully for Tesla and also for Volvo the decision to try to be cheaper. So when we think on lightweighting, of course, we have some options due to the integration of stiffeners and also some geometry details. But on the other hand, we know that shell structures have sheet thicknesses of 0.7 and less and higher strength. There we can have really lightweight design where we have limitations within the gigacasting. So this is always when we think on lightweighting and also in the gigacasting, that we have a target of conflicts and also many other drivers to do these solutions. So I think I'm really grateful that we are now talking again on principal options to realize body in white, because then we can try to find the best. And of course, we have still many problems within the gigacasting. And I also expect, like always, the next generations that the Gen 2, Gen 3, Gen 4 will have a different shape and different realization topics. But I'm really happy that we try to do things in a different way and to find out the optimum at the end.
I will bring Ignacio and Jerome in on this, Wolfram, but I just wanted to ask you, and I'll ask them the same question, actually. We'll put it across the panel. You mentioned there, like, it is interesting to see I say new approaches, but different approaches towards body in white, towards lightweighting and vehicle structures. And you mentioned there being cost effective and particularly flexible in production. Are processes such as megacasting are not that on its own, but are these kind of processes that are being developed now, are they game changers? Would you define them as game changers for the OEMs? I'll just come back to you in the first instance, Wolfram, if I may, and then I will put the question across to Jerome and Ignacio, if that's okay.
So, sorry, again,
So I was just asking, do you see the technologies like megacasting, the way that then it's kind of the way that OEMs are approaching, do you see it as like a game-changing technology?
Let's say at the moment, to be honest, I would say it's an option. So it's a game changer that we have a significantly reduced number of panels. But at the end, we must prove that it's really cost efficient and also repairability. And so we have many other problems. So at the moment, it's an option where we have to prove that it can be developed to a game changer. So I won't say that is a game changer at the moment, because also when we think on these high strength steels and shell structures, and also when we think on brownfield and greenfield, when we have done the investment in a press shop, we will use it, and then we will have good options and cheap options for lightweighting in a conventional way. But when we have a greenfield approach and we want to prevent these investments, then I think there can be a game changer. So at the moment, it's an option we look at, but it has a potential, but I won't say that it's really a game changer at the moment. So there's still a big way to go.
Okay, thank you. And to bring Ignacio in on this, if I may. Again, obviously, we just mentioned that, and you're aware of that. I know it's not necessarily an area that's where Gestamp is operating, but obviously your perspective on vehicle structures, and you've been working for a very long time. I know in R&D specifically. I know from meeting you previously. So, what's your perspective on megacasting as part of the process? One of the options that are out there, but also, do you see kind of game-changing processes? Is this kind of journalistic hyperbole?
Yes, I would say that the gigacasting can be, let's say, a game changer, but not so much because of the gigacasting, the use of high-pressure die casting in aluminium, more because of the concept to build the car within 3 or 4 big, huge components. So a front, a rear component, where you can integrate with gigacasting a lot of function, as Wolfram explained correctly. But on the other side, this mega component can be made of other materials too. And this is a development line where we are working since a few years, where we are capable today on hot stamping, the so-called giga stampings, do the same size of components, but made of hot stamping materials to integrate there the functions and get the same idea, build a car with a very low number of huge components. And that is truly possible today, like we do in the one-piece door rings on the side of the cars, while we are using extreme high-strength material, like 1,500 megapascal, we can add today 2,000 megapascal to these designs. And this leads to very light products, and with these light products as well for really an ISO performance, in some cases much less CO2. So the game changer, I would say, is the idea to build in a new manufacturing plant of the OEM, to build the car in the fastest way. And there, big components, we believe, are the right direction, and maybe this is the game changer, building big components.
Thank you. And we're going to come back to processes in a minute, Ignacio. You mentioned a couple there. I want to come back to those. Jerome, can I ask you what your kind of views are? I mean, Jerome and Ignacio and Wolfram have both sort of said, that there is a sort of but there is a sort of change in perspective that other options are being considered, and the opportunities are probably there as well. We're seeing more opportunity in materials and processes. What's your view on? I'm slightly hesitant about the game-changing label to it, but what are you, on the big changes or the big opportunities in terms of body in white and lightweighting?
Sorry, I think I was on mute.
That's okay.
Yeah, first of all, I just want to confirm that I fully agree with what Ignacio just shared. With very large stamped parts, we are also able to propose very interesting amount of part integration, interesting level of part integration, which leads to gains in manufacturing, and more especially in lead time reduction, and also in capex. On our side, regarding the material and solution development, we worked also on similar concepts via our AMTB company. So with the idea to provide laser welded blank, and here the idea is to go a bit further and propose indeed different thickness level and different materials. As also Ignacio just mentioned, we can have combination of different mechanical properties, which helps to have on a very large part a very fine tuning of local thickness and mechanical properties. And indeed, this is also possible because the products were developed with that idea of having a kind of robustness, end of robustness, and end of process stability to allow this mix of different grades and thicknesses and have nevertheless a robust process. And here on our side, it continues for us to be a source of innovations, and not only to design and apply this technology for other modules, but also to develop the materials. I can give you the example of a coating we have recently developed, which is called ThermoBoost. So here, as you know, this kind of very large laser welded blank are suitable for hot stamping, which is a process which need, before being formed, a heating step of several minutes in a furnace at very high temperature to get an austenitic state of the steel. So it means that we have to heat the blanks. And because of the different thicknesses, we may have some limitations. So this is why we bring to the market now the ThermoBoost coating, which allow, in fact, to increase the heating speed of the thicker blanks, which helps at the end, in fact, not only to be able to heat or to find a wide enough process window and robustness in the process, but also to decrease the heating time, give CO2 reductions, and so on. So it shows that this large part integration are also a great source of innovations for the material suppliers, and there are numerous opportunities for us.
Thank you. And while I've got you on, Jerome, I'll start. I've got another question here, which I kind of going to lead on, but I wanted just to get a sense. And I know from ArcelorMittal's point of view, there might be a slight bias here. I don't know, but I mean, in terms of, we're seeing the multi-material approach to lightweighting has kind of been developing, and it was always kind of in high-end cars, premium cars to some greater or lesser extent. I'm not sure it's necessarily become massively mainstream in high volume at the minute, or whether it ever will do. But do you think the idea, and now that the joining technologies, the forming technologies around multi-material have matured and become arguably more cost effective than they perhaps previously were, do you think that multi-material has leveled the playing field or made it easier for engineers in respect of where we are now across sort of material choices?
Mm-hmm. Multi-material is a quite complex topic, because indeed the cost of the assembly could be a limitation. Here, if we speak about steel, we tend to increase the mechanical properties, and usually the most efficient way to assemble different materials together is the mechanical joining. And here, for example, if we start to increase mechanical properties above 1500 megapascals, we start to have to think about some more exotic process, which start to be expensive and technically also difficult to master without providing possible damage to the parts. So regarding the multi-material assembly, I think that today we are in a state of the art, and frankly speaking, I saw no real recent developments which could help to cut down the cost and continue to push for more multi-material cars. Yeah.
Thank you. And Ignacio, I mean, again, you're working around vehicle structures. I know from Gestamp there's a huge amount of work around all the body structures. And I know that you've, I think, visited one of your R&D centres it's not just steel. You do have different materials. You're doing a lot of simulations around. Now, what's your view on the kind of multi-material approach?
Yes, multi-material mix. We used a lot of these solutions, but we are always aware that multi-material means to put the right material combination on the right place. But you need to pay always these 4 extra levers, which means different joining technologies, different corrosion properties, different tolerances, and a higher cost. And these are the 4 main levers which are belonging to this multi-material mix. And you have a lot of advantages. As we said, we can use different properties of material really on the right place. But we do that really only if we cannot fulfill the requirement with a mono-material solution. And there, for example, as Jerome also explained, and the tailored material that you can do with, for example, hot stamping, you can really get different thickness, different hardness grades, with no different joining methodologies, which results at the end in a much, let's say, optimum cost product. But always there are applications, especially in electrical vehicle, where the forces in crash are so high that sometimes we really go to multi-material mix and have to pay this extra cost and problematic around the 4 levels.
Yeah, and we're going to move on to actually the EV structures, a little bit about performance and materials involvement in that. And Wolfram, if I can come to you, what's your perspective on the multi-material approach?
Let's say I found that in the last years we have a different view on multi-material, especially when we think also on the recycling effect and sustainability. Because when we have a combination of steel and aluminum, we have problems to solve them also in the total cost of ownership. And that's the reason why we try to bring more monomaterials, because it's it's simpler and easier in a recycling perspective. On the other hand, the multi-material offers us so big options for us to say the real effective lightweighting, because we can have lightweighting options of tension and compression, where we are in the crash path where we need ductility, and also we just need high strength materials and so on. Because if we don't use multi-materials, we also have a compromise in materials in the properties. And typically the best lightweight construction is multi-material, but on the other hand, with a joining and recycling effect. And I think this is also the way how much we are willing to pay for 1 kilogram loss in mass. And this is a question which is still open also for electric vehicles. What is a real number to count on? And where it is. So when we think on aerospace, we have totally different solutions, and that's also that for when we think on fiber reinforced plastics and so on. But there we have seen that it's not the option. It's removed from automotive because the money we have to pay was too high. So this is effective lightweight design, and I think this is where we really try to go on. And so I agree with Ignacio that at the moment I don't see that these multi-material and hybrid designs are a big player, more these integration solutions.
Thank you. And if I may, that brings me on to another question I kind of got written down here. Is kind of in terms of priorities, how do you see OEMs balancing the need to reduce EV weight against the increasing costs around materials and associated technologies? I mean, Jerome, if I can just come to you, obviously, I know you're working on the S in Motion projects with ArcelorMittal, which are around, and they're evolving. They're not just a project; they're an evolving a series of designs and iterations. But you're working very closely with as a supplier with the OEMs and tier suppliers. What's your sense of how they're doing this sort of performance cost balance at the minute? I mean, is it a bigger challenge now with the EV vehicles?
Yeah, let's say that it's in the recent history. Let's say we have heard different things about that. And let's say for internal combustion engine, we always had a target about euros per kilogram saved, which could be more or less €2 per kilogram saved accepted, generally speaking. It's true that with battery electric vehicles, the topic was open again. In the beginning, some people were saying, no, it makes no sense because with regenerative braking, for example, we are able to recover the energy, so weight saving makes no sense. But at the end, people discovered that indeed lightweighting continue to be important also for battery electric vehicles. First of all, because we have always losses due to the efficiency. And then because battery electric vehicles also need to be attractive and technically attractive. So it means have a higher range. And to increase the range, nevertheless, because of efficiency, we have to reduce the weight. And if we reduce the weight, we can also reduce the amount of battery. So we have a kind of circle. So indeed, today, lightweighting is still very important for the battery vehicles. Difficult to say what could be the target, what would be the optimum to be found. I think that now we should start also to think with a sustainability perspective. So it's true that today we have no legislation on that, not yet. Maybe it will come in the next year, but maybe based on a future legislation, for example, we could estimate what could be the euro which could be spent to save 1 kilogram of CO2 equivalent emission, for example. And I think that in the future we will more and more go to that direction. That cost will of course be important. Lightweighting, yes, but in a perspective of sustainability to avoid also all the trade-off we could have. For example, you can use very, very light materials, but if you are not able to recycle them, or if you emit a lot of CO2 emissions to produce them, it makes also no sense. So today the picture is not completely clear because we need also, we have to see what will provide the next legislation on that, but it's definitively the way the automotive industry is following today.
Thank you. I appreciate that. It's quite a tricky question to ask. I'm just interested to get the sort of Ignacio. Can I come to you on that one? Because obviously, again, working with OEM and tier suppliers, and I mean, it's interesting because we see the innovation, the engineering, the materials, and as Jerome mentioned there, sustainability is another cost factor that's now been added into the mix of considerations when the OEMs are deciding what route they want to go. How are you? What's your view on their way they're kind of balancing it?
Yes, till now, let's say every gram really counts, and it was our development target to make that lighter. I would also like, this is also coming because of two issues. The dynamic of the car is directly linked to the mass and to the weight. And the second one is the crash requirements are getting higher, and as more heavy a car is, as more complex the crash will get. So in this sense, lightweighting is extremely still important. And then on top of this, and this we see every time more, as Jerome pointed out correctly, is the sustainability. So the CO2 reduction that we actually can reach is coming from simply designing the products lighter. So if a product is really lighter, we have less raw material, and raw material is equivalent to the biggest portion of the CO2 emission on raw material basis. Till we do not have really zero emission aluminiums or zero emission steels, which are on the way to the 2035, at least to a big portion, lightweighting is the only way to reduce, let's say, the CO2 by getting some material out of the car. This is like a linear function.
Yeah. If I may just add one comment, fully agree with Ignacio. If we reduce the weight, we reduce the CO2 emissions, but if we think about same materials, just if we switch indeed, for example, from the steel to a carbon fiber, for example, or magnesium, of course you reduce the weight, but at the end, it's not sure that you reduce the CO2. It's just one component.
Yeah, no, so we agree to this. Is making a design, no, and the following design with the same technology or with at least with the same material, then there is the saving, no.
Exactly. This is why advanced lightweight steel will.
But also
be attractive for automotive.
Yeah. An interesting motivation for lightweight, also especially in Europe, is the so-called driving license lightweight. because especially for larger cars, we have the problem of the 3.5 tons. Because you need a different driving license if you are heavier than 3.5 tons. And especially the larger cars now with 1 ton of batteries inside, they have a big problem with it. And then it's also something funny that for vans and SUVs, they must be lower than these Frontier. And then companies are willing to pay really much money that it's still possible with a driving car license to drive the car, and you don't need this first class of lorry license. So also some interesting, beside all these CO2, some practical issues, which is especially important for European cars.
Thanks, Wolfram. That's a complication I wasn't aware of, and that's just added to the list. But it's really interesting. Again, you know, there are things outside of the manufacturing operation that are weighing on the decisions that are being made, the investment that's being made. I'm going to come on to some process related questions in a minute. We've had a question here which I want to direct to you, Wolfram, if I may. It's around. This is from our audience. I just wanted to feed this in. Yeah. In regards to the gigacasting, do you have any estimations around the scrap rate for gigacasting? Because apparently our audience is saying they're not getting very clear information on that.
We must be aware that for casting solutions, the process window is very, very small, smaller than typically for forming solutions. So always, if you bring to a market a new casting solution, you will have much pain in the ramp-up phase. So I expect in the ramp-up phase, typical numbers are 70%. We must be aware. We have high porosity and so on. But typically, with the intelligence of our engineers, at the end, we come up to scrap rate, let's say, around 5 to 10%. So this is the target, what we have to reach. I don't know at the moment if we are really in the maturation phase, but it's definitely 10 times higher than for metal forming applications where we speak around 1%, 0.5%. So I think for the gigacasting, when you reach a scrap rate less than 10%, you have really done a good job. I think it's realistic, but we still have many problems to go. I'm not sure if all the companies are there, but you must be aware in the ramp-up phase, the scrap rate is very, very high. That's also why we have different sayings. Please be aware that you can't say that the scrap rate of the ramp-up phase is that what you have after the maturation. But I don't want to be in the position of these process engineers because it's really much pain.
Yes, sometimes it does seem a very unenviable position, doesn't it? But they enjoy this problem solving. Ignacio and Jerome are a testament to that. Look, they're always smiling whenever I speak to them, no matter what the challenges are. It's bread and butter. And we're moving on to that. I just wanted to move on to we touched a bit. Jerome and Ignacio touched upon a few new sort of processes that are out there now. And if I may go to you first, Ignacio. I mean, the idea was I wanted to sort of, we're obviously talking about this sort of mega casting was kind of one idea, but what alternatives are out there? And you mentioned something, and I would like to know a lot more about is kind of the mega or giga stamping that you discussed there. I mean, sort of a bit more detail about what that means, the implications, and where that might go in terms of future production.
Yeah, this is it's in terms of giving an answer to the OEMs to build cars with more reduced cycle time, so reaching the famous 10 hours, which in some cases Tesla is claiming. We believe that big components are needed. So we developed a family product we call it extreme size parts, and these extreme size parts are made of giga stampings. Some examples are the one-piece side ring of a car, front and rear door. In the extreme, we can make or develop a one-piece floor system where the complete 24 components are built in one door ring. And now we are on the way to launch this one-piece rear rail in one component. Advantage there is We're playing with a much higher strength level, and sometimes 3.5, nearly 4 times more than the aluminum, reaching ISO performance to the other components which are today on the market, but at least with a much reduced cost level. And these families of gigastampings, we believe, is the right solution to build a car in a very fast way, at the same time offering a product that integrates a lot of function inside and is lighter. And again, lighter, less raw material, less CO2. So it looks like that in the moment is a solution that can be made of monomaterial, giving to the customer at least a lower cost of assembly, as they can weld these products and not need to use very fancy multi-material applications.
And are there any process requirements for that? Are there any additional process requirements for that?
No, there is. Yeah, no, there is right the big advantage. We are using the same equipment that we had before in hot stamping. We need to adjust this equipment. In some cases, slightly elongate the furnaces. There are some minor changes, but basically we can reuse existing capex, which is a big advantage for a company who runs like Gestamp more than 100 press hardening line, to really adjust our equipment on capex that we have on the market for electrical vehicle. So we have a good answer for the problematic of electrical vehicle by using existing capex and not inventing or getting into new, different, risky investments.
And if I might ask Jerome to sort of feed in on this, because I know that Arcelor have been working on a number of different projects, and you alluded to a few of them. I mean, could you just give us again alternatives around here? The approach. I mean, the gigastamping is fascinating, and it's interesting again trying to reduce the number of parts within a component or a part of the vehicle. Could you give us some insights into some of the things that you've been working around and things that you see out there, or even a glimpse maybe into some future projects?
Just unmuting myself again, sorry. Yes, indeed. So on our side at ArcelorMittal, we have, let's say, similar concept. So the idea is to have very large parts which integrates a lot of different parts which are stamped in only one operation. So the idea for ArcelorMittal is to deliver the complex laser welded blanks. And here, in order to help the product development, to identify also opportunities, and also for us to identify the value we could provide to the customer, we have some design activities to identify what would be the best application case for this kind of large integrated parts. So as Ignacio mentioned, you have the rear rails, which could be compared more or less like the high pressure die casting from one side of these assemblies, but we do have also the double door rings. We have also the throw reinforcement, which are stamped in one part instead of having 6 or 7 parts stamped separately and then welded together in the body assembly. We continue to work in other innovations, and this is clearly a focus for us to continue to develop and to see how we can further provide gains and integrated concept to the customers with our new steels, and to better understand what is the limit of the steel we are proposing to reach this ultimate targets of having the most simplified possible body in white. So this kind of concept are called at ArcelorMittal the MPI concept, multi-part integration.
And I've seen that it's really ingenious as well. I mean, again, this is we kind of watch the development of the way things are going forward. Wolfram, if I can just put that question to you from your perspective, where do you see the kind of new technologies that might be, or new processes, materials? Where do you see in terms of this lightweighting? Where do you see kind of maybe next step being?
I'd say the really next step. What we are also working on at university, where we have some good examples, is the topology optimization and the bionic design. Casting is there a good option, but not high pressure die casting, because typically it's high pressure die casting is also for shell structures. But when we think on core package and these technologies, we are really able to have this force flow optimized structure of a car, like the bionic design. And there we also have developed new production technology with these inorganic sand binder jetting and so on, where we have serious ready solutions also for big volumes to have these bionic optimized structures of a car. And I think there can really a big step forward in lightweight design, when we don't think in these shell structures, but also in really in these topology optimized ones. So really looking forward to find partners to do in that case, that it's not only high pressure die casting, but also other casting technologies where I think we can really do a step forward within effective lightweight design.
And that, you mean by that bionic, you meant including those cast parts within a standard steel structure or aluminium structure? Yeah. I just wanted to go back. We were talking about Ignacio certainly, and I'll come on to you, Wolfram, with as well. But Ignacio and Jerome, talking about the steels that you're making now, and processes that you can make some particularly hard steels. The performance of these steels is really impressive, and what you can now do with them. I just wanted to ask the question in terms of joining and forming, and I know you touched upon it a little bit earlier, Ignacio. Have developments in these processes kept pace with the development of the materials that are now being or available to the car makers and the OEMs? Because it's great having a performance, but if you can't form it or join it particularly, that must be a challenge. So do you feel that those processes have been keeping pace? Can I come to you first, Ignacio, please?
Yes, we believe that it's following. The forming and joining processes are following very close. We can get at the same speed. That's also one of the reasons why we are building our own tools. So we are a tool maker. We're building all our own tools in-house, having therefore the simulations, everything in-house, which allows to adapt to new materials as soon as they are coming. On joinings, we have to do it with laboratories, but I think the speed of the joining doesn't matter if it is let's say a mechanical joining, a laser or a friction joining or adhesive. They are following the speed. But you're right, new materials are coming on the market in electrical cars on such a speed that we are sometimes need to hurry up. Just one example, the fire protection solutions that are going into the batteries now. These are new materials, could be fibers or minerals. And when you need to put this type of materials joined to our classical steel, aluminium or whatever, then the joining has really to adhesive solutions need to hurry up in the race. But I would say roughly we can match the speed of appearing new materials with these joining and forming technologies in all cases.
Thank you. And Jerome, can I bring you in on that one as well? I mean, what's I know having interviewed you and worked with you before, it's a key thing when you're developing the grades, the formability, the joining. So what's your view on that? Do you share Ignacio's view on that?
Yeah, but indeed, like I fully share Ignacio's point of view, but it's true that on our side also, when we are developing materials, we always also think about the already established customer, which already has a production line. So in order to help them to bring a very optimized solution, which could be implemented at the lowest possible cost, we also very often consider the existing process. Even if sometimes it needs some upgrade, it's rather incremental than breakthrough. But regarding weldings, it's true that it's a key topic. It's a key topic, especially for advanced high-strength steels, because here we have different phenomena which could happen. But nevertheless, it's a topic we are handling, but from the material perspective, where we fine-tune, let's say, the chemical composition to ease the processing at the customer. But anyway, I agree to my opinion. For the time being, regarding the development pace of the technology, I think it's adapted and suitable to the solutions we are proposing today with steel.
Okay. And Wolfram, do you have a view on this? What's your view?
I think we talk about many things about optimization, but I think it was also what Ignacio said. We have to rethink our target functions, and because we are coming from a history of many years where we had a classical shell structure where we had the optimization, but now we have so many changes that sometimes it's impossible at the moment to really have a detail on the target functions for our optimization. And this is changing rapidly in different directions. So we need flexible solutions and also in the combination to fulfill these requirements. It's also when we think on the storage housings, is it implemented in the crash path or not? And if you just change some of these things, then the material is changing to total, and you need good optimization algorithms to fulfill these basic ideas. And I think at the moment we have, interestingly, at some OEMs, requirements which are from the classical combustion engines and just bring it also to the new vehicles and not to rethink also these basic target function. And I think here the new player in the market really start from zero and try to really bring these requirements to a next level, what is really important for the cars and for the customers. And I think here we have a big issue also with all the joining technologies. Please go back and ask really, is it necessary what we are used to do? And then we have big options for optimization and new cost savings and weight savings.
That's really interesting because, I mean, obviously we do see development, but obviously we're dealing with established technologies as well. So if there are incremental changes, but as you said there, Wolfram, maybe there's a need for a rethink, or maybe that's the right approach. And you touched upon something there, and I think this, I mean, we talked about the challenges across the whole thing. We take EV as a core product. I mean, digital tools. So are these going to be key to making EV architectures cost effective from a materials and forming and joining point of view? And if I'll jump in with Ignacio on that if you want to start off.
Yeah, digital tools are a very essential part of the development. You would distinguish between two parts. Now, one is everything related to the Industry 4.0, so like digital twin on our machines, which allows us to run the equipment with much more accuracy, where we have a better connectivity, we have an optimized production, what leads at the end to a more cost-effective process. So this is one side. But the other side is we're working a lot on design tools, or new design tools like development of model order reduction, which are new softwares that we try to co-develop with partners, in which we can, during the design of the product, have a directly link to the crash behavior of the complete car. So when we're designing a product, let's say a door ring, we can see the effect of morphology, of thickness, of strength. What is the direct effect on the full crash of the car? And these softwares still not full operative, but we'll say we are maybe on 80% or 90% of finishing. This allows us to design much faster, accurate solutions and validate this in a shorter time and more accurate with, let's say, faster possibilities. This is, I think, the future where we are working with Gestamp.
You mentioned partners there. Is that partners on developing the software, or is that partners in terms of tier suppliers or OEM partners in terms of what?
No, in this case, it's both. We have OEM partners who are doing that with us, and as well as the software companies. Yeah. So, both.
Thanks. I've been given my warning countdown, but I'm just, if I can, going to steal an extra 5 minutes because I've got a few more questions I'd like to ask, and I don't want to kind of. So we've got to cram at least one more question in. So Jerome, I'll just come to you on that question regarding digital tools. Again, I think I've seen some of your presentations. Yeah. So if you could just give me a quick update on what your view is on that.
So to my opinion, it's absolutely important to have more and more intelligence on these topics because, okay, in the past, we were focusing on the weight, on the crash, on the cost, and now we add also sustainability. And everything together is not linear. And it's impossible to follow and to find the optimum in the way you are designing currently the car step by step. And here at ArcelorMittal, for internal activities, we have indeed developed also a software which help the designer to choose from the beginning, before launching the first crash simulation, to have a first view of what would be the picture, depending on where we want to put the focus, rather on sustainability, on cost, or on lightweight. It is definitively important because, again, if we speak about sustainability, we have to consider that you have different materials together, but also between materials, you have decarbonized materials, you have different recycling contents, and depending with all the sensitivity, the picture is extremely complex to be drawn. And the only way to get the optimized design is to use and develop this kind of tools, which are still needed, let's say, to be developed. And that's, to my opinion, the only way we can get an optimized design, knowing that here, again, the crash is, of course, a #1 concern, but also battery technologies and so on. So there are numerous interactions which makes that we need to jump into AI for this kind of topics.
If I can just ask Wolfram, how digital tools are helping you with your research?
Yes, let's say it's essential, but I also have to put some water in the wine, how we say it in German. Because when we think on new technologies like the gigacasting, and if you do a total new technology, it's impossible to have the maturation of the digital tools like on conventional technologies. And that's also a big issue for the managers, how much risk we take and to bring also new solutions into the market. So it's like hen and egg, and sometimes we need the pain of the real production as the driver for developing our digital tools. So of course we are doing both, but on the other hand, sometimes we have to do it to really go saturated, because then you're too slow for really new breaking technologies. So this is, we have to take some risk.
And that's very interesting, because we often think of digital tools solving everything, and obviously there are established ones that do enable a great deal of development. But it's a very interesting point of view. I've got probably time just for one more question, and forgive me if we do run out of time. The question really is, I mean, I know, speaking this is probably around Jerome and Ignacio, the importance of collaborating between engineering and manufacturing, which is why I was asking about the partners before, Ignacio. So I know you do always have done work closely with OEMs, but we know that partnership, certainly in sort of the upstream of design, is becoming much closer and much more detailed and involved. Could you just kind of comment on that, around the importance of that, and just sort of quickly?
Yeah, this development together with the OEM, we call it co-development. It has to be in a very early stage. With a lot of OEMs, with most of our customers, we're working this co-development. Means 5, in some cases, even immediately after a car is launched, we are involved in the next concept of the next car. And with this very early involvement and being on a similar level to propose new innovations at this moment, we can reach, let's say, much more new solutions for lightweight into the car, as if we are very nearby to an RFI of a customer. And this is, we can see this mainstream, that most of our customers are asking for this co-sharing and co-development, and we see that very positive.
And that even extends into sort of software design and algorithms for specific kind of application areas.
Yes, especially this is the holy grail of most of the car makers, because this means the interchange of the crash system. So in most of the cases, we can have an interchange of a crash system with an OEM, and where we can work really on the same problematic. And this is a big advantage. And I think it's a partnership where it's fruitful for both parties.
And I'll just bring you really quickly in, Jerome. Sorry, if we can just have a little comment from you on that. I know you've got obviously a lot of experience in working. Just your views on that as well, in terms of how far upstream. We've only got like literally a minute.
Yeah, okay. But yes, indeed, very short. So I think link between manufacturing and engineering should be also reinforced. I will just take the example of the new steel grade advanced high strength steel with always higher mechanical properties. So we may have some increasing sensitivity, for example, to spring back, which are in fact a kind of not-wish geometry compared to the tool design. And here it is going to be assessed only with experts from forming and from manufacturing. And this has to be, in fact, designed in a loop. If you want to design a car which is manufacturable with this grades by keeping design efficiency, we should have the loop and consider also much more the manufacturing constraint than what we do today. And it's likely it requires likely some change at our different OEMs regarding the way to organize the work, but it's a must do.
Thanks, Jerome. Appreciate that. Right, well, I'm going to have to bring the session to an end now. I want to just thank you to Wolfram, Jerome, and Ignacio for your time and insight. It's been fascinating talking to you. I've got a load more questions, but unfortunately, I'm now out of time. Thank you for joining us this afternoon, and stay tuned for our next sessions. After that, I'll say goodbye.